Polars expressions, very much like Legos, they're like building blocks that give you superpowers. And I like expressions so much that today I want to tell you all about them, why they're important and why they're elegant. Hi, my name is Jeroen Janssens, and recently, together with Thijs Nieuwdorp, I wrote a book, Python Polars, the Definitive Guide. And yeah, when I'm not writing books, which hopefully will be for the foreseeable future, I'm doing developer relations at Posit, the company behind tools such as Shiny, Cordo, Positron, and also Grade Tables and Plot9, which I want to mention to you. There are currently 2 competitions going on. So if you're into creating grade tables, right, and by the way, that is the default way of when you're styling a data frame in Polars, it's actually using the grade tables package behind the hood. So, or if you're into data visualization, then I can recommend that you check out these 2 competitions. The deadline, I believe, is October 3rd. I'll include a link at the end of this presentation. Back to Polars. All right, we've heard it all before. Yeah. Come for the speed, stay for the API. It's even entered pop culture. And, you know, the good thing is that when it comes to the API, I'd say that about half of it is expressions, right? And that's a good thing, because if you grok, if you fully understand expressions, then you're halfway of mastering Polars. Right? Your typical Polars query is essentially a glorified ETL job, right? You extract some data using 1 or 2 read functions. Then you do a whole bunch of transformations. Yeah? And this is where expressions really come into play. Yeah? And then maybe 1 or 2 lines of saving your data, again, to a database or to a file or what have you. When Thijs and I set out to write our book, we envisioned a single chapter about expressions. Oh, how naive we were back then. We didn't need 1, we didn't need 2, we actually needed 3 chapters to fully cover expressions and what you can do with them. We even had to include a diagram to explain to the reader what these 3 chapters, how they're organized. And when just yesterday, I counted the functions and methods within the Polars library. Yeah? And even there, depending on, you know, if my method was correct, you can see that about 50% of those methods are related to expressions. Let's have a look at some examples to give you some intuition of what an expression is before we really dive into the definitions. Yeah? Oh, by the way, I should mention that if you have any questions, I really like it when you ask them in person and when you ask them immediately. So when inspiration hits, or confusion, immediately act on it. I appreciate any question. You can wait till the end, but it's definitely not needed. And if there is a question from someone who is attending virtually, your question can be submitted using the app, and they will be read out loud. Okay, some examples. Let's start with a simple data frame containing 10 fruits. Yeah? 5 different columns with different data types. And now let's apply 5 common transformations to this data using expressions. Selecting columns using the dfSelect method. Here we have a variety of expressions. And an expression is most often started using the pl.call function, which you can give the name of an existing column. You can also give it a regular expression, as we do here in the second expression, and that leads to 2 columns being selected. So that's quite expressive, right? That you can use a single expression to get back 2 series or even 2 columns that are being returned. You don't have to specify an expression to this select method. You can also specify a string, but which might be convenient because you have to do less typing, but then you won't have all the advantages that an expression gives you, like doing arithmetic with them, as we do here with the weight column, which we divide by 1,000. You can create new columns using the with columns method. Notice that it's not a verb. And let's see here. We're using 2 different ways of giving a name to this column, right? Either the alias method or using a keyword argument. Right? Both have pros and cons. What I also like about expressions is that a lot of methods are organized into namespaces. There are 9 namespaces, and one of them is the str namespace, which contains all the methods related to string operations. We can filter using the dffilter method, and here we're actually combining 2 expressions into a single expression. You can use arithmetic, comparison operators, Boolean operators to combine multiple expressions into one. Aggregation using the group by method. Notice the underscore in between group and by, especially if you're used to pandas. Now, each unique value of the expression that we give here will lead to a separate group, right? And also notice that we're actually using expressions in 2 different places here. One, to determine how data is being aggregated, or to determine the groups, and then how the individual values are being aggregated into single values. Yeah. Sorting using the dfsort method. Let's see here. We can just as easy sort on columns that don't exist. We can sort on expressions, right, that are not in the data frame. And also notice that this will not create it will not create a new column. That's another thing to keep in mind as we look more closely at what an expression is. So, what is an expression actually? Yeah? So now that we have an intuition of what expressions look like, what they can do, let's dive in and look more closely. So here's the definition that is in the official Polars documentation. Yeah? And they define an expression as a lazy representation of a data transformation. Yeah? And here is Marco Gorelli's definition. And he defines an expression as a function from a data frame to a series. Can you tell that Marco is a mathematician by training? And they're not wrong, these definitions. They're also not, they're kind of complementing each other, right? There's some overlap here, right? It's transforming something, but one definition highlights the lazy aspect of it. And here it's like, okay, it takes in some data, a data frame, and it produces a series. Well, we've already seen that it can also do multiple series, so we'll come back to that. So I believe that even though these are not wrong, I believe that we can do a little bit better, right? And of course, I have to justify spending so much time on coming up with one, which is, something that you do instead of actually writing. You start doing other things, and one of them is coming up with a definition because it makes you feel good. So take this with a grain of salt, right? What I want you to walk away with is a good mental model of your own of what an expression is and what you can use it for. So I define an expression as a tree of operations that describe how to construct one or more series. So that's quite a mouthful. So let's break it down. Let's start with the series part here. So series, not necessarily a column, as we have seen with sorting, right? Not every expression yields a new column to be added to a data frame. Right? So that's why we've used the constructed term here. A series, yeah, an array, a list, a sequence of values. It's a tree of operations. You can use the meta.tree format method on an expression to get a glimpse under the hood and see how it is actually being represented. Well, maybe not so much internally, but also more mentally, to get a glimpse of what it looks like. Yeah? So it's a tree-like thing. Not every expression has to be a tree, but they have the ability to become a tree. And especially when you combine multiple expressions, right, using either arithmetic or comparison operators or Boolean operators, you will end up with a tree. Right? They describe how to construct a series, one or more series. Right? They don't actually do the things themselves. They're lazy. They're merely a recipe of how to do something. Right? That's also what the definition in the official Polars documentation used. They're lazy. And this has a lot of benefits, as we'll see later. Construct, right? I've already hinted at this. One or more. So let me give you another example of one or more series. Here I'm using the pl.all function to refer to all the existing columns in the data frame. Yeah? And so there are 2 columns to start with, and so this with columns method will then add 2 new columns, because we're also changing the names of the expressions. Otherwise, those 2 columns would be changed themselves. Yep. All right. Are there any questions about this? While I drink a sip of water. Oh no, Marco. Marco, what is your question?
Okay, I'm angry. Why do you say that blueberries are not round?
Say again, sorry. Blueberries are not round? Did I say that? Oh my. I knew you had something to blueberry. Well, yeah, you know, in a mathematical sense. So, right, Stephen.
I'm trying to link expressions to 2 ideas that I think I understand, that I think are similar, and maybe you can clarify if you think they are or they're not. One is like the method chaining in Python or pandas that you might use.
Yep.
And then the other one might be the pipe in R.
Yeah.
Please, can you link expressions to those 2 things? Because that's how I'm trying to understand, yeah.
Right. This comes up a lot, right? In R, you have now the native pipe operator. In Unix, we've had the pipe operator for decades. And Python users will typically say, but we have method chaining. They're not the same. When you use method chaining, you're bound by the methods that the package provides you with. Whereas with a pipe, you can use any function. You can use functions from other packages. You can use your own functions, if you will. So pipes are a lot more flexible in that. They're a lot more versatile. But still, if you are using method chaining, yeah, you're changing. So a method is a function bound to an object. Yeah. So conceptually, there is still some similarity to a pipe, given that you're being returned the same type of object, which is also the same as when you're using the tidyverse, right, in R. Yeah.
Is expressions method chaining?
You are method chaining, yes. When you're using a dot, you're method chaining. Now, with these namespaces, there are additional dots, right? So you have to get used to that. It's not, yeah. So you're not immediately applying the SDR method, right? SDR is an accessor which provides additional methods. Also, when you're using arithmetic or Boolean operators in Python, those are actually defined as methods as well. Yeah. Yeah. I hope that answers your question. I mean, when you're using R, you're very much spoiled with the pipe operator. And there have been attempts in Python to introduce a pipe operator, but Python is just way too object-oriented for that, to make that work. Yeah. One more question. Or at least for now. Like I said, I encourage each and every question.
Yeah, exactly. Maybe you will cover this in more details later, but if not, can you elaborate a little bit on the laziness, this describing?
Yeah.
What you mean by that in more details?
Yeah. So an expression. So if I can elaborate a little bit on the describing part of, or the laziness of an expression. Thank you. So an expression by itself doesn't do anything. It is merely a description of what should be done. And an expression itself doesn't know to which data it will be applied, yeah? Or by which method it will be used. Yeah? So if you think of an expression as a recipe, yeah, then the various methods which accept expressions, select with columns, filter, sort, group by, and so on, they are the cooks, yeah, who use that recipe. And this also, the laziness, and we'll get to that as well, this allows pullers to optimize these descriptions. So it is able to make as few calculations as possible to come to the result. And it is even able to execute multiple expressions in parallel because of this, because of their lazy nature. And it becomes even better when you're actually using a lazy frame instead of a data frame. Then pullers, the optimizer can even optimize higher level steps, right? So it can reorder reading and filtering and whatever makes for the most efficient computation. Thank you. There was a question in the back there.
Yeah, really quick question. So does the laziness persist between the filter and select? So can I do filter and then some aggregation, and then the pullers would be able to optimize based on the aggregation that I applied? Or I do filter after, okay, it doesn't make sense, but I do filter that would inform me that I wouldn't need to do some operations. Would that work there?
Yeah, so if I can rephrase your question, can pullers optimize across different methods being applied to a data frame? Yeah. And the answer is no when you're in eager mode, yeah, which is what I've been presenting so far. But when you're in lazy mode, when you use the lazy API, and you can start that by either using a scan function instead of a read function, so scan CSV, scan per K, instead of read CSV and read per K, or you start with a data frame and you apply the lazy method, which turns it into a lazy frame. Then, then you write your transformations and your expressions as you would normally do. Yeah? And then at the very end, you use the collect method, which will then materialize into a data frame. It will turn that lazy frame back into a data frame. And when you do that, when you're in lazy mode, that's when polars, when the optimizer has the opportunity to optimize across methods. So indeed, when you're applying a filter, sometimes it's able to do that filtering already when you're reading in the data. So it becomes really efficient. Yeah. All right. Thank you for all those questions. I really appreciate that. So I have 10 minutes left because of this. I'm totally okay with that, but it might mean that I have to speed up a little bit. And that's actually not a bad thing. I noticed that it's getting pretty warm up here. Do you see me sweating at all here? Okay, good. It is hot here. Okay, so because of all this, there are some properties of expressions, and we've already covered some of those, so I can go a little bit faster here, right? By themselves, they're lazy. They don't do anything. They depend both on the function or method that uses them and the data to which they're being applied. Right, so here we define an expression called isOrange, right? They're just Python objects, so you can assign them to a variable. And I can use that expression to create new columns, to filter it, and to group by. I can really reuse this expression. And to really drive this reusability aspect home, you can even apply an expression to different data frames. That's pretty neat. I think, the ability that you can sort of separate those things and make your expressions, give them an informed name, that can really help make for readable code. Right, they're expressive. This is a bit of an opinion, but they just look good, right? The way you can, combine them, apply all these different methods, it looks good. They're also expressive because you can apply things to multiple columns. So in that way, they really allow for concise code, which I would say is also expressive. They're efficient, right? Because they are lazy, polars can optimize them before they are executed. And they're idiomatic, right? Let me give you an example here. If you have seen pandas code, then you may be familiar with this syntax. And this actually works in polars too. But it's definitely not recommended. It runs suboptimal. First of all, the optimizer cannot optimize them. Right? They're executed in serial rather than parallel, and you can even run into errors when you take this approach, right? When you so here I do have the same example. It's actually a lazy example in this case. So first an idiomatic version and then a non-idiomatic version. And if you just read this, then you may think that they will yield the same result. Well, in effect, the latter, where you use the non-idiomatic syntax, definitely not recommend, it actually leads to an error. Yeah? Because the fruit data frame is being updated along the way. But you're still referring to an object, a data frame that you think has 10 rows. Well, in fact, polars has determined that it's only 2 rows because of the filter. All right. Last but not least, expressions. They're important, not only for polars itself, but also beyond. And there are 2 cases here, and they can actually be attributed. Credit where credit is due, to Marco Gorelli, who started the Narwhals project, and and now, of course, there is an entire team behind this, I've learned today. Right? We've seen, if you have seen his incredible keynote, I'll make sure to include a link in the description below. Narwhal's expressions are inspired, right, very much by polars expressions. And it goes even further. So Marco Gorelli, he even introduced expressions back into pandas. So those are already two places where Polar's expressions are making an influence. With that, we've come to the conclusion here. So I hope I've given you enough arguments of why expressions are both elegant and important. Right? And when you do, when you take the time, it may take you some time, especially when you're used to pandas. When you have come to understand them, then I would say you're at least halfway there of becoming quite dangerous with polars. Thank you very much.
Thank you. Questions? Checking there. No question. Yeah.
In the example you showed before with the expression that you used for another, you saved it, like you assigned it to a symbol, right?
Yeah, let me get to that.
Right.
This is where I define it.
Orange.
Yeah.
Right.
Yeah.
And then 2 slides later, when you use it on a different data frame, I found it a little bit, you mentioned readability, but it's actually counter-readable here because you don't know what is orange at this point. It's kind of...
So I think that, to rephrase the question, it's actually less readable here because here we may have forgotten what it is orange actually is. And I think that's more because of that I'm using slides. If this were to be in the same code base, then, or maybe we should give it a better name, right, to make it more recognizable. But of course we use variables in our code all the time. Right? So why wouldn't the same benefit apply to expressions? I think this is mostly because they're on separate slides. But I might be wrong. It is personal.
If you print out this orange object, it gives you a pretty representation, and you can see what the expression is doing as well.
Oh, thank you, Marco. So, sorry, Marco Gorelli. Thank you. Grazie mille. If you can print it out, and then you get a pretty representation too. So especially if you're working in an interactive environment, then that works too. Yeah. Thank you. That's a good comment. You're not convinced yet. We'll talk about it afterwards.
Hi. Thank you for a very nice talk. When attempting to use polars within PyTorch data loaders, I've sometimes met some issues. I think with some of the parallelization, where I get some issues where Polars complains about something about how the parallelization starts, and I think PyTorch maybe does something differently. Maybe that's not a common use case, but do you know where that might come from, or what I can do better?
So to summarize, you're having issues combining polars and PyTorch? Yeah. I'm afraid I have no experience with that. So maybe if someone else here does, maybe you can find each other after this talk. But thanks for bringing it up. Yeah.
Okay, one question.
Thanks a lot for the talk. So my superficial impression as of now is that things such as the expression API, also lazy evaluation, and potentially method chaining all sort of pay into this idea of higher abstraction and maybe having a slightly more declarative feeling to it, which I think, as you allude to, can be very elegant and really neat if it works. But I'm wondering if you have thoughts on how to combine that with maybe a more iterative workflow that we often need when, for instance, debugging things, right? So if we have all of this complexity sort of batched up together, how do you think about debugging problems and finding the details in between this whole chain of transformations?
Yeah, good question. So if I got it right, so how do you debug especially a Polars query that consists of multiple methods that are being chained? And this is a good point. There are ways, although I cannot really reproduce them at this moment, to insert methods into your chain of methods to print out intermediate results. There are ways to do that. Although in practice, what I typically do is when I develop my Polars query, it is very much an iterative experience. I start off with reading in some data and then gradually adding more and more transformations to this, maybe do some rearranging later. But you're right, there might be a situation where you want to look at intermediate steps as well. And I must say that I haven't found really a good way to do that other than changing the code. Yeah, so that's a little bit unsatisfactory, I can imagine. But I can imagine that more people encounter situations like this.
Okay.
Thank you. Oh yeah. Okay, that explains why you weren't convinced yet. But thank you for bringing that up. And there might be ways to do this. So if you have found a way to reliably debug or to look at intermediate steps of longer Polars queries, let us know.
Yeah, unfortunately, we are over time. It's quick question, maybe one last one.
Yeah, just generally, if you use a lazy all the way through, I would not recommend breaking up your query, just because your broken up query might do different steps that the optimized query does. And then the question is so basically, is there a way to get what the optimized versions look like from this expression?
Yes, there are methods to. So the question was, you first made a comment, you recommend breaking up longer queries, especially when you're in lazy mode?
If you have a lazy query that's all the way lazy, I would not recommend breaking it down to debug it, because you might get a different steps. Because if you break it down, the optimizer is going to optimize it differently.
Oh, yeah,
So
yeah.
then I would actually look at what optimizer optimized, so the representation of that expression after
Yeah.
the optimizer worked on it, and try to debug that.
Yeah, so to get an idea of how the optimizer optimizes, there is, I believe it was describe graph? Show graph, thank you. Show graph, and that takes an argument optimized. You can set it to true, and then you can compare the non-optimized and the optimized version of your Polars query. Also, a good point, if you do break up your Polars query into multiple blocks, then you may not get to the same optimized version. Still, sometimes you do need to do that. There are situations where the optimizer is not as smart as caching results, so it may be doing the same work multiple times. But we can talk about that afterwards. Thank you very much, and thanks everybody for your attention and your questions.
Thank you very much.